Okay, we're recording.
Good morning and welcome back to a new week of our course. We are still continuing with the whole idea of how to cope with big data and data science. An important part of how we do that is an exciting new technology that people are beginning to use more and more. It's called learning, machine learning. And then it turns out that it has quite a rigorous mathematical foundation. So this week's lectures will be focused on the algorithmic foundations, as always in this course, of learning theory. Once again, the course is co-developed with Professor John Augustine of IIT Madras. And in this case, the student collaborator who partnered with us on creating this material is Mr. Shreyas Shetty, also from IIT Madras. And to acknowledge the source material, we are basing what we are going to be discussing in class this week, including notation and other concepts, for the most part, quite substantially actually, on the book by Michael Kearns and Umesh Vazirani. So the outline of topics in this lecture would be a broad overview of why we care about machine learning, a particular form of algorithmically well-grounded learning schemes called PAC learning, which we will see in a second, stands for probabilistically approximately correct learning. So we are increasingly going to depend on what we saw in the prerequisite lecture on the basics of probability. See some basic definitions and notation, as well as the model itself. Remember that from earlier lectures, we saw quite a bit about Boolean functions in the context of representing them through spectra of what we call the Fourier spectrum of Boolean functions. The Fourier spectrum is a way of discerning, and we learned that in the previous weeks, how sparse or dense a function is. Now we will try to do something new with these Boolean functions, apply this PAC model to effectively learn them, and we'll see what that means, of course, where once again sparsity is a major point of focus for us and will be something we quantify quite rigorously as we've done in the past. So let's start now with a broad overview of what the motivational elements behind machine learning are.